Homework 6, Section 3.4, Logical Arguments, Video 8. Before we move on to the next important idea, there is one key word that I forgot to mention in the previous videos, and that word is called a fallacy. A fallacy is simply an argument that leads to an invalid conclusion. So for example, when we had the argument P conditional Q and negation P as the premises with the conclusion of negation Q, that was an invalid argument, so this argument is known as a fallacy. This is actually a pretty common fallacy that people fall for. I'll give you another example. Premise number 1, if I get a raise at work, then I will get a new car. Premise number 2, I did not get a raise at work. Conclusion, can you conclude I did not get a new car? The answer is no, you cannot. I only said what would happen if I got a raise. I didn't say what would happen if I didn't. Maybe I won a big poker game. Maybe I won a drawing for a car. There could be a lot of other reasons why. So an argument where you draw a false conclusion, an invalid conclusion, is called a fallacy. But that's not really what this video is about. This was just tying up a loose end from the previous videos. This video is about common valid argument forms and common fallacies. Common valid argument forms and common fallacies. In fact, we've already seen one of each. There are 4 common valid argument forms and 3 common fallacies. You will not need to memorize them, but you'll need to be able to recognize them if you have them in front of you. When we did the first argument, we had a conditional. If I stay at home, then I will not catch COVID-19. A premise that matched the antecedent of the conditional. I stayed at home. And the conclusion that we drew was Q. I will not catch COVID-19. This was a valid argument form. We've already done that. Go back and check the previous, I want to say it's 2nd and 3rd videos. But this was a valid argument form, and in fact, it's a very common argument form. This argument is so common, it has a name. This is called the law of, why did I just freeze? Detachment. So any argument that translates symbolically into this is automatically valid. It doesn't matter what the words are, it matters on the structure. For example, let's say you have an argument of the following form. If, I don't know, if Jimmy Fallon, I think that has 2 L's, likes sushi, then let's say that, I don't know, Lady Gaga is a physicist. Now, I'm not saying this statement is true or false. We'll just say it's our first premise. And then our second premise is Jimmy Fallon likes sushi. And then somebody draws the conclusion, Lady Gaga is a physicist. Is this argument valid? Now, I'm not asking if any of these statements are true. I'm pretty sure the last one isn't. I don't know her that well. The second premise could be true or false. I don't know if Jimmy Fallon likes sushi. And again, the conditional, I don't know if it's true or false. But we're not asking, are these statements individually true or false? What we're asking is, would this conclusion necessarily follow logically from these premises? Well, if we were to translate this argument into symbols, the first premise is a conditional. We can call Jimmy Fallon likes sushi P, and Lady Gaga is a physicist Q. And so our first premise would just be P pointing to Q. Our second premise is Jimmy Fallon likes sushi, which we already called P. In our conclusion, Lady Gaga is a physicist. We've already called that statement Q. And so by translating this argument into symbols, we see that it exactly matches the law of detachment. And because it matches this, it is automatically valid. We've already proven that this argument form is valid. This is the law of detachment. Therefore, it's a valid argument. So yes, you could conclude that Lady Gaga is a physicist if these two statements were true, and the argument is valid. Again, the statements individually may be true or false, but that's not what we're asking. We're asking, must this conclusion follow from these premises? And in this case, the answer is yes. So we've already seen one common valid argument form, the law of detachment. And we've already seen one common fallacy. The second one that we did was a fallacy. The one that said, premise number one, if I stay at home, then I will not catch COVID-19. But then the second premise was the negation of P. I did not stay home. And the conclusion was the negation of Q, which was I will catch COVID-19. But we've already set up the implication for that, ran the truth table through, and determined that the argument was actually invalid. This argument form is very common, and unfortunately people incorrectly draw conclusions. If I don't study, then I will fail. Let me restart over. If I study, then I will pass. I didn't study, therefore I didn't pass. Not necessarily. You might have cheated, you might have gotten lucky on a multiple choice test, but this statement only says what will happen if P happens. It does not say what will occur if P doesn't happen. This fallacy is called the fallacy of the inverse. Why is it called the fallacy of the inverse? Well, if you go back to the video about types of statements where we talked about variations of a conditional, one of them was called an inverse. So if you just want to recall, and this is what I call a thought cloud, recall that the inverse of a conditional, P pointing to Q, you form the inverse by taking the negation of both the antecedent and the consequent. So negation P pointing to negation Q. So that's what the inverse of a conditional is. Also, an inverse is not logically equivalent to the conditional. And what that meant was you can't just negate both halves of a conditional and get an equivalent statement. The reason this is called the fallacy of the inverse is because people mistakenly think if I have an if-then statement that's true and I negate both halves of it, then I guess that's also true. No. But if you think that, then symbolically, here's what you're thinking. Oh, this statement and its inverse are the same, so I can just cross it out and replace it. And if you did, then this is actually the law of detachment. I know it's loaded with negations, but remember what the law of detachment says. If something points to something else, and the first something is your premise, then the second something is your conclusion. If the inverse were logically equivalent to a conditional, then you could correctly draw this conclusion. However, the inverse is not logically equivalent to its conditional, which means you cannot draw this conclusion. You're incorrectly drawing this conclusion because you're making a false assumption about the inverse. And that's why it's called the fallacy of the inverse. Now, you don't have to remember why it's called the fallacy of the inverse. You just have to know the following. If your argument looks like this symbolically, it is automatically invalid. There is no need to do a truth table. Now, I mentioned that there were 4 common valid argument forms and 3 common fallacies. In the next video, I'm going to list them all, but we're not going to verify that they're valid or invalid. But if you ran the truth tables through, you would draw those conclusions.